Hello, in this video, let us describe Arrhenius acids and bases, a subtopic under acids and bases. Arrhenius acid and bases. The definition is quite very basic, and it was improved over time. Arrhenius acids are acids that, when dissolved in water, they create hydronium ion, which is H3O+. Okay, so let's say that you have H2O, the oxygen has the lone pairs, and then let's say you have an acid like HCl. We know, as discussed earlier, that you have dipole moments, which suggests that chlorine has more share of the electron density between them, having a partial negative charge, and hydrogen will have a partial positive, because absence of electron density equals presence of positive charge. So this hydrogen is going to be the acidic hydrogen. We're going to call it a proton. Acids are proton donors. We'll discuss that in Bronsted, improved Bronsted definition of an acid. So that hydrogen will be donated away, and it is donated to the oxygen of the water. So in this case, the water plays the role of a base because it's going to accept that hydrogen, and then these two electrons will be given to the chlorine because it's more electron wanting, more electron deficient, more electron rich, more electron wanting, let me say so, more electron negative. So we will eventually have this product. When H2O takes out the acidic hydrogen, the H2O will be converted to hydronium. This oxygen will be partially positive because, again, if you do the formal charge, oxygen has a valency of 6. There's 2 non-bonding electrons. There's 3 bonds around it. You subtract all those, you get +1. That's justification for that plus charge. This is going to be called the conjugate acid. It came from the parent base. The chlorine fell off as a leaving group. It left the relationship between H and Cl, and it will take a negative charge because valency of chlorine is usually 7, but now you have 8 electrons. You have 1 extra negative charged particle called an electron. Otherwise, if you do formal charge, chlorine has a valency of 7. Remove, subtract non-bonding electrons. There's no bond on it. You're going to get -1. That's another way to do it. It's negatively charged. It's the conjugate base in the product side. So when water is dropped, when HCl is dropped in water, it's showing to give us hydronium. And so we say that HCl is an Arrhenius acid because it gives H3O+ in presence of water. This is a simple equation of reaction. These right here are the reactants, and these on the right side are the products. So the reactants yield products on the right side. Okay, what are Arrhenius bases? Let's consider a species like sodium hydroxide. Okay, one would have written it just as NaOH. Drop it in water. Arrhenius bases are species or compounds, chemical compounds that form hydroxide ions when dissolved in water. So in this case, it's the ionic compound that's just gonna ionize. Okay, it's gonna ionize in water, and as it ionizes in water, it's gonna break up to give you hydroxide. So that's what already I'm suggesting right here. This compound right here is ionic. In water is gonna ionize, and you'll get OH minus and Na plus. And these ones will be dissolved in water as aqueous species. These two are aqueous, but the aqueous species we are having down here that we are interested in is the hydroxide. So anything that dissolves in water to readily gives you hydroxide is gonna be called an Arrhenius base. Other examples will include, let's say, calcium hydroxide, potassium hydroxide. Those ones will give you OH minus when dropped in water. I hope that helped.